this is your CBNST, that subject that we have your class, and that has been the class is your 18th class of the session. In the last classes we had started with unit 1 only. In that the name of the unit is your computer arithmetic errors roots of equation, and where we had done many of the subject topics that we had done is your secant method, bisection method, Newton-Raphson method, iterative method as well, and the iterative roots method as well. So here we're going to continue with finding it out, the decimal, the initial values, and that should be answered up to the 4 decimal place or 5 decimal place. That is being using the successive approximation method here. Before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. So here we go and start with the first question of the session, and that the 57th question of this unit. Let's go ahead. Find the roots of fx equals to 8x cubed minus 6x minus 1 equals to 0 using successive approximation. With this, that has been the successive approximation method. Take initial value as x0 is equal to 0.95. Your answer should be correct up to 4 decimal places. So for that given equation, 8x cubed minus 6x minus 1 equals to 0. So 8x cubed equals to 6x plus 1. Further it is 2x equals to 6x plus 1 की power 1 by 3. That has been x is equals to 1 by 2, 6x plus 1, 1 by 3. And for that here, let's take x equals to 1 by 2, 6x plus 1, 1 by 2. That has been equals to I dash x equals to 1 by 2 into 1 by 3 into 6x plus 1 minus 2 by 3 into 6, which is equals to 6x plus 1 power minus 2 by 3. Then 5 dash 0.95, it is equals to 6 into 0.95 plus 1 power minus 2 by 3, which is equals to 0.281 less than 1. So it termed as x is equals to 5x. So on the same case, xn plus 1 equals to 5, and xn we'll take x0 is equals to 0.95. so when we put the value for that, we'll take x0 equals to 0.95. the formula we have is your that xn plus 1 equals to 5xn, and we'll go ahead for x1 is that is being equals to 5x naught, which is x0 minus equals to 1 by 2, 6x0 plus 1 power 1 by 3. We'll put the value here, that will get here is your the value 0.9426. Now we go ahead for the another one, which is x2 is equals to 5x1 equals to 1 by 2 6x naught 6x1 plus 1 की power 1 by 3, which is equals to 0.9452. Now we talk about for x3 here as well, and that is being for x3 is equals to 5 of x2, and which is equals to half 6x2 plus 1 power 1 by 2, and that is being equals to 0.9399. For next we have x4, we'll talk about it, that has been 0.9398. Then for x5 equals to 0.9397. For x6 is equals to 0.9397. And for x7 x6 as well, and then we'll have your, in the same case, x5 is equals to x6. So the root that 0.9397, that is correct up to 4 decimal places here. Okay, so now we go ahead for the next one, which has been the solutions of polynomial equations using the synthetic deviation here, which is of course been important one. So yeah, we go ahead for the same, and that we have your formulas for the same as well. So here, solution of polynomial equations using synthetic division. So for the same, the formulas we have, and that is for the Birch-White method, that gives the next approximation of the root of the following equation. So the formula we have for that is just p1 is equals to p0 minus bn upon cn minus 1. Here p0 that is of p0 is initial approximation, and bn and cn minus 1 are obtained by synthetic division here. For improved values of that roots, that to be given here is p1 is equals to p0 plus delta p, and q1 is equals to q0 plus delta q for that here. And for the delta p, we talk about it, which is when we finding it out, the formula we have minus bn cn minus 3 minus bn minus 1 cn minus 2 whole upon c square n minus 2 minus cn minus 3 cn minus 1 minus bn minus 1. And for talking about that delta q equals to minus bn minus 1 cn minus 1 minus bn minus 1 minus bn cn minus 2 whole upon c square n minus 2 minus cn minus 3 cn minus 1 minus bn minus 1. So that is all the values on the right hand side of above equation that are obtained of synthetic divisions here. Now we go ahead further, which will discuss the Birch-White method. For the Birch-White method here, that the roots of the polynomial equation that can be obtained using your synthetic divisions, let us take it the polynomial fx of degree n, that b is like this: fx equals to a naught xn plus a1 xn minus 1 plus a2 xn minus 2 plus an minus 1 x plus a n. For that, let p be the approximate estimate of the roots of fx, and then synthetic divisions that is performed to obtain the detailed polynomial, which is to be given as, and that is being representing like fn minus 1 x equals to b naught x n minus 1 plus b1 x n minus 2 plus b2 x n minus 3 plus bn minus 2 x plus bn minus 1 here. So you have to note that the factor x minus p of the first degree is extracted from the equations, and above equation is obtained as a quotient as well. So the next real root is obtained using deflated polynomial, and the synthetic divisions is to be given in the following, obtained being 0, b1, b2 and b till bn minus 1 as well. So we'll made a table for it, and that has been the synthetic division table that we are made here. For p, that has been a naught, a1, a2, an minus 2, an minus 1 and an. So we made it for it. So for that, it is being here, and that is for b, which we have representing as a value. So we'll go ahead further. Like this only. So now we'll put the values for this. When it is your p only, then it will be your the a1 will be p b naught p b1 p b n minus 2 n minus 3 and p b n minus 2 and p b n minus 1. When it is p, then this is being b naught is equals to a naught, b1 is equals to a1 plus b naught, b is 0, that is b3 is equals to 8 b1 b n minus 2 b n minus 1 and bn is equals to r, where r is the remainder. Okay, now for the next, it is here, that is being for a1 only, that will named out as b, when b a naught c naught b c1 b c n minus 3 and b c n minus 2. After that, we'll take a conclusion here, and that will be bring it up like for a naught, it is c naught is equals to b naught, c1 is equals to b1 plus bc naught, c2 is equals to b2 plus pc1 cn minus 2 and cn minus 1 here. This is for the synthetic division here. So let fx be the polynomial of the degree n, and that is being fx is equals to, we have, and for that we have your fx is equals to a naught xn plus a1 xn minus 1 plus a2 xn minus 2 plus plus a n minus 1 x plus a n. So let the initial approximation of the root be p naught, which is p0. So according to the Birch-White method, the next approximation of the root is to be given as, and we named as like b1 equals to p naught minus bn upon cn minus 1. So this relation that can be recursively expressed as, this is named as pk plus 1 equals to pk minus bn upon cn minus 1, that is being k equals to 0, 1, 2, that we have. Now we go ahead for the question here, which we'll talk about it, and that has been the important one, of course. So for the same, it will be, the question is, using Birch-White method, find root of x4 plus x3 plus 5x2 plus 4x plus 4 is equals to 0 at the end of two iteration with initial value of x naught is equals to 1, or you can say that x0 is equals to 1. I have to compare the given equations, and for that it will be a naught x4 plus a1 x2 plus a3 x plus a4 equals to 0. For that, a naught is equals to 1, a1 equals to 1, a2 is equals to 5, a3 is equals to 4, and a4 equals to 4, and p naught is equals to x naught, which is equals to 1. So for iteration 1, we go ahead, we'll make a table for it, and following table that shows the synthetic division, and then for iteration 2, that another table being made. So we go ahead for making a table for iteration 1, and that's what we have to solve it out, and after that we will be further putting the value and then implement that. Let's go ahead for the same. For iteration 1, that we have p naught is equals to 1. So we'll put the value here that we made it. So with the same, we made for iteration 1, and that is we have to make a table here, and for p naught equals to 1, it will be a naught is equals to 1. For a naught equals to 1, and a1 is equals to 1, then for a2 is equals to 5, A3 is equals to 4 and A5 is equals to 4. For the same, it is your B0 equals to 1, B0 B1 is equals to 2, B0 B1 B2 is equals to 7, and B0 and B3 is equals to 11. Now for another, it is your B0, which is equals to A0, that is equals to 1. For that, it is B1 is equals to 2, B2 is equals to 7, B3 is equals to 11. For P0, C0 is equals to 1. So P0, C1 is equals to 1 or 3. P0, C, that is your 2 is equals to 10. For the same, it is your C0 is equals to B0 equals to 1. C1 is equals to 3 and C2 is equals to 10. Now we'll go ahead for iteration 2. That would we have to talk about it, and that's what we even though have to answer it out. But before that, with n equals to 4 and k equals to 0, so for that it is p1 equals to p0 minus b4 minus c3 is equals to 1 minus 15 upon 21. It will give you 0.28571. For iteration 2 we talk about here, and that what even though we have to discuss here. So for iteration 2, it will be that what we have to go ahead for following table that will show the synthetic division with their calculated values, and for that it will be P1. For P1 we find it out, we made a table. So here that is P1 is equals to 0.28571, what the value we had find it out, and of that we have to find out for A0 is equals to 1, A1 equals to 1, A2 equals to 5 for the same, and that's what we have to talk about. A3 is equals to 4 and A4 equals to 4 as well. So for that we have to find out. So we go ahead further. P1, B0, your B0 multiply 0.28571. P1, B1 0.36734. We go ahead for the same, and that we have A3 is equals to, which has been your P1, B2, and that has been multiplied 1.53350. B1, B3 is multiplied by 1.5808. A01, that is being B1 is equals to 1.28571. B2 is equals to 5.36734. B3 is equals to 5.5335. So for that it will be P1 C0 is 0.28571, P1 C1 0.44897, P1 C2 1.66177, and for that it has been C0 equals to P0 equals to 1, C1 is equals to 1.57142, C2 is equals to 5.81631. So for the same will be with n equals to 4 and k is equals to 1. So we'll put the value P2 is equals to P1 minus B4 upon C3 equals to 0.28571 minus 5.58097 upon 7.19527, which is equals to minus 0.48993. So thus the approximate value of the root at the end of the second iteration is, that is being x2 is equals to P2, which is equals to minus 0.48993, that is being equals to minus 0.49 that we have. So here we're gonna end up with this on before ending it off, we had talk about sociology and software engineering. Even though we had done your chemistry, where we had completed your unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9, with their conversions, logarithms, antilogs, and that what we had done here. After talking about that as well, we had done your which has been we had done many of the things. We are dealing with ER diagram, we are dealing with English vocabulary, we are dealing with quantitative aptitude. Other than quantitative aptitude, we had done your reasoning, and in reasoning we had done your verbal reasoning, which is including the general mental ability and the logic reasoning. In non-verbal reasoning, we had done series analogy, classification, analytical reasoning, mirror image, butter image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangle, figure formation, analysis, and practice question set as well. After talking about that, yes, we had done your quantitative aptitude we are dealing with. In that we had started with arithmetical ability. In that we had done operations on numbers, as if and LCM of numbers, decimal fractions, simplifications, square roots and cube roots, problems on numbers, problems on ages, surds and indices, percentage, and profit and loss. That has been the 11th topic we are dealing here. Coming to a CPNST, that has been the computer based numerical and statistical technique. In that we had started with unit 1, which has been the computer arithmetic errors and your roots of equation. In that we had covered up the floating point arithmetic, machine obstacle, round off error, stopping errors, truncation error, associative and distributive law of floating point arithmetic, inherent error, error propagation, numerical instability. Roots of equation we had done second method, Newton-Raphson method, fixed point iteration method for the simple roots and derivation of their rate of the conversions, Atkinson's accelerations of conversions, modified Newton-Raphson method for multiple roots, Birch-Biter for multiple roots, Weierstrass method for the quadratic factor, and computer algorithm of these methods. That's what we have to cover up here. And then after that we complete unit 1. We'll start with unit 2, where we have to cover up the interpolation and curve fitting. In that we have to cover up the algorithm and the error analysis of the Lagrange and Newton's divide and difference interpolations, relationship in the various difference operation, piecewise linear interpolation, cubic spline interpolation, natural spline, Chebyshev's polynomial approximation, Langkow's economizations of the power series. In curve fitting we have to cover up the linear and nonlinear least square approximation, third conditioning in the least squares methods, gram schematics, a process of orthogonalization, computer algorithms of least square curve fitting. In unit 3 we have to cover up the differentiation interpolation, that has been the method based on the interpolations and the finite differences, Radicans extrapolations and integration. We have to cover up the errors analysis of a trapezoidal and Simpson method, Newton cross integration method, Gaussian's integration method, Gauss-Legrand method, Lobato integration method, and the Radau integration method, error terms in the integration method. Then in unit 4 we have to cover up the solutions of simultaneous linear algebraic equation. We have to cover up the Gauss elimination method, conditional systems, conditions number, successive over the relaxation method, rate of convergence, solution of ordinary differential equation. We have to cover up the single step method, Runge-Kutta second order, third order and fourth order method, multi-step method, predicator corrective method, statistical technique. In statistical, the hypothesis, test of hypothesis, type 1, type 2 error, level of significance, test involving the normal that is distribution. We have to cover up here. So here we're gonna end up with, and before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.